Hello friends, we are talking about different processes to remove contaminants from water. In last lecture, we talked about electrodialysis and today we are going to discuss about ultrafiltration and reverse osmosis. Here we are going to discuss on similarities and differences between two processes, how exactly this process works and compare both processes. I am Audumba Patkar and this is lecture 14 of the module Water. Now let's see what are similarities between two processes. Both this ultrafiltration and reverse osmosis are membrane filtration techniques. That means in both processes, impurities from water are filtered using membrane and detent. And membrane used in both processes are either made up of synthetic carbon material or cellulose material. And only difference you can find between two processes is pore size of filtration membrane, where you can see ultrafiltration has pore size around 0.01 micron and reverse osmosis a pore size 0.0001 micron. Now let's see how ultrafiltration process works. In this diagram you can see ultrafiltration membrane is shown as dotted line, where gaps indicates pores of membranes. When we apply hydrostatic pressure on liquid, solids of high molecular mass will retain, while solvent and solids with low molecular mass will pass through the membrane. Hence, you can find the applications of this process to separate molecules with different size. Industries such as chemical, pharmaceutical, food, beverages, wastewater treatment employ this process. Specific examples are it is used for paint recovery in automobile industry, also used for the fractionation of milk and whey in dairy industry. I hope you are aware with the process osmosis, where solute moves from low concentrated site to high concentrated site through semi-permeable membrane, where in case of reverse osmosis, solvent flow reversed, that is from high concentrated site to low concentrated site by applying pressure on high concentrated site greater than osmotic pressure. This can be better understood by the help of this animation. Here you can see how reverse osmosis plant look like. Now let's first see what osmosis means. It is naturally occurring process in which solvent spontaneously passes through a semi-permeable membrane which allowed to pass only small molecules like water. The flow of solvent through such membrane is to maintain even concentration of salt on both sides of membrane. Hence, here solvent flow from less concentrated area such as fresh water to high concentrated solutions such as seawater, as you can see in this animation. However, when direction of solvent is reversed, it's called reverse osmosis. By pressurizing concentrated solution, in this case seawater, we are able to force solvent water in the reverse direction from seawater side through the membrane to freshwater side. This membrane filtration is also called as superfiltration or hyperfiltration. Here we observe that by applying hydrostatic pressure more than osmotic pressure, solvent is forced to move from concentrated side to dilute side across the membrane. This process can remove ionic as well as non-ionic, colloidal and high molecular mass organic matter with low capital cost, operating cost and high reliability. Now let's summarize both processes. Both ultrafiltration and reverse osmosis are membrane filtration techniques, where pore size of membrane is different and hence applications. Here you can see in ultrafiltration process solvents, salts as well as dissolved organics of small size can pass through this membrane. While in case of reverse osmosis, only solvent like water can pass through the membrane and all other salts, dissolved and undissolved compounds can retain. So this is all about ultrafiltration and reverse osmosis. In next lecture, we will talk about biochemical oxygen demand and chemical oxygen demand. Thank you very much. See you next time.